go. Hello, Abigail, Jackson, and Molly, I think is who I'm recording this video for. This is 3-3. I'm not going to go for too much time, like 15 minutes, I said, and then I'm going to give them time to work in class on the 3-2 homework because some of them don't have that done. That's fine, whatever. 3-3. We're going to do just a little bit of this, okay? I want you to really huge circle z-score. Okay, we're going to define a z-score, but we will be using a z-value or a z-score of some sort from like here throughout the rest of the school year. Like it's a huge important thing, okay, z-score is. So you need to make sure you understand what z-score stands for, what it means, okay? So a z-score, are you ready? Everybody's data value is assigned something called a z-score. And the z-score is the number of standard deviations that a value is away from the mean. The number of standard deviations that a value is away from the mean. Okay? All right, so let me do an example for you so you can kind of get that. The number of standard deviations that we are away from the mean. All right, here's my example. There you go. Okay, I'm going to do an example over here. Example. I'm going to still use this example. X bar is 85. This is like scores on a test with a standard deviation of 5. Okay, I've been using that same example this whole time, right? Okay, so that means if I slap 85 on a number line, one standard deviation on either side would be at like 90 and 80. Okay, two standard deviations would be at like 75 and 95. Let's just do those two because I'm running out of room. Okay?
Didn't we learn z-score before?
What?
Before the high, if it's higher.
What do you mean? Okay. All right. So here's my example. And I've done two standard deviations on either side. Okay, so when we're talking about z-score, we're saying how many standard deviations is it away from the mean, okay? So I'm going to ask you a question. What I'm writing is with a Z, is the z-score for 95? What is the z-score for 95?
2.
How many standard deviations is it away from the mean? You're exactly right. 2. That's the z-score. Make sense?
Why didn't we learn the z-score before the...
Because it's a little bit more in depth than this, okay? Because it won't always be a whole number, okay? What is the z-score for like 75?
2.
-2. Z-scores will be negative. If it is negative, that means it's below the mean. If it's a positive, that means it's above the mean. Does this make sense? Z-score of 2. Okay, now, let's say, for instance, that I have a score of a 93. Okay? Let's say I have a score of a 93. What is his z-score going to be? 1.5 maybe-ish, right? Okay? So we have to have a formula for finding z-score when it doesn't come out as a whole number, right? Okay? All right, so we're still trying to find how many standard deviations he is away from the mean. So we agree that it's like a little bit more than 1. 1 would be here and then a little bit more than that, right? Okay? So here's how we find z-score. Ready? It is, I like this formula better, right here. Sample standard deviation is x minus x bar divided by the standard deviation. Okay? So if we're trying to find 93, the z-score for 93, we figure out first this part, which is how far he is away from the mean. How far from average. Okay, that's what x minus x bar does. How far are we away from the average? What is 93 minus the average of 85? Okay, but then we take that and we divide by the standard deviation, which is 5. Okay, so 93 minus 85, that tells me how far above average we are, right? What will that be? Like 8? 93 minus 85 is 8?
Yes.
Yeah? And if we divide that by 5, what's 8 divided by 5 as a decimal?
1.
At 1 3/5, which is 1.6. His z-score is 1.6, and that's what we guessed, right? Okay? So all we're doing for z-score is how far are we away from average? Divide by the standard deviation. That tells you how many standard deviations you are away from average, right? That's what the z-score is. What happens if you have a z-score of 0? then you're on the average, right? Does that make sense? Z-score of 0, you are exactly on average, okay? Does this make sense? Okay?
This is 8.
Okay, I'm doing lots of examples over here. So, what's considered to be significantly high and significantly low
2.
as far as Z-scores go? If you have a Z-score that is higher than 2, you're significantly high. That's what it says right here. Significantly high Z-scores are greater than or equal to positive 2. Significantly low Z-scores are people that are less than or equal to negative 2. Does that make sense? 2 away, right? Above 2 or below negative 2, that is the significantly low, significantly high people. Make sense? Yes? Okay, so Z-scores are expressed as numbers with no units of measure. It's just a Z-score. No units of measure. So if you're dealing with like height, your Z-score doesn't have like feet or inches on the end of it. It's just a Z-score, okay? It's a score. All right, number 4 says an individual data value less than the mean. The Z-scores are going to be negative numbers. So you can have negative numbers for Z-scores. If it's negative, it's below average. If it's positive, it's above average. If it's exactly at 0, you are on the average. Make sense? Yes? Okay. All right, let's do an example. So which of the following 2 data values is more extreme relative to the data set from which it came? This is why we do Z-scores. I can find which one is more extreme based on different scales. Like yesterday we were talking about ACT versus SAT, and I said which one is like has more variation. Well, they're on 2 different scales. One goes from 0 to 36, one goes from 0 to 1600. We are on 2 completely separate scales. So now I'm trying to find which one is more extreme. So let's read the options. Here we go. It says the 400-gram weight of a newborn baby, 4,000 gram weight of a newborn baby, or a 99% temperature for an adult. Which one is more extreme? Okay, we have the average for a baby is 3152. So is this baby more overweight, or is this person have a higher temperature? Does that make sense? Which value is more extreme? Which value is higher relative to its scale, right? Okay, so this is why we do Z-score, all right? So we have the average. This is the X bar. We have the standard deviation, which is this guy, and we have the value that we're going to use, which is 4,000. Okay, so let's figure out the Z-score for this top bullet point. And so we do X minus X bar. What is X in this case?
4,000.
4,000. X is my value, 4,000. And we subtract 3152. And we divide by the standard deviation, which is 693.4. Are we going to be above average or below average? Above. So our Z-score is going to be positive, right? A positive number, okay? So let's figure out what that positive number is. 1.2. So this value, that birth weight of 4,000 grams is only 1 and a little bit more standard deviations away from the mean, right? It's a little over 1 standard deviation above the mean, okay? Let's figure out by temperature. 99 degrees doesn't seem like a whole lot, right? But we do 99 minus the average. What's the average again? 98.2. Okay, and we divide by the standard deviation, which is 0.62 degrees. 1.3. So which one has a more extreme value? The temperature one. Temperature equals more extreme. And when I say more extreme, that's like how out of the ordinary is it, right? Okay, so like having a temperature of a 99 is more out of the ordinary than having a baby that's born at 4,000 grams, right? That one's more an extreme value, more out of the ordinary. Make sense? Yeah? Okay, so we've talked about significantly high, significantly low. Values that are not significant are here in the middle between 2 and negative 2. Those are the people that are just kind of normal people, right? Okay, significantly high values, significantly low values. Okay, can you have a Z-score that goes up to like 10?
Yeah.
If you're 10 standard deviations above the mean, you betcha. Very rarely will that happen. Usually your your Z-score will be a number between -3 and +3. Every once in a while you'll get a number that's like 5 for a standard deviation. Okay, or a Z-score, I mean. Very rarely though. Most of the time your Z-score is going to live between -3 and +3, because what percent of data lives between -3 and +3 did we learn yesterday? Do you remember? 99.7% of all values are going to live between -3 and +3. Do you remember that from yesterday? That laminated sheet that I gave you, okay? So most of the time your z-score will be between -3 and +3. Every once in a while you'll get like a 4 or maybe a 3.5 or a -5, something like that, right? But not very often, okay? So as you're doing this, if you're getting numbers for z-scores that are like 7s or 15s, you're probably not doing the process right? Or switching some numbers around, okay? So there's that. All right, so example 2, the lowest platelet count in data set 1 body data is 75. So I'm gonna write that down. Low equals 75. Okay, anytime you see any of this information, just write it down lower, below, so that we can find it easier. The platelet counts are measured in 1,000 cells per whatever that is. Microliter or something like that? Is that a microliter? I don't know what it is. Okay, is the value significantly low? So we want to know significantly low. That's what we're trying to find. Significantly low, question mark? We don't know for sure. The average for those values, can you find that number?
Yeah, 239.
239.4. The standard deviation is 64.2. Okay, so let's figure this out. We're doing z-score. We're going to calculate z-score, right? Okay, and the z-score we do what? X. What's X? 75. The 1,000 is not a number that we're even going to use. That's just telling us how they're measured. They're just trying to throw extra numbers in there to confuse you. 75 minus 239.4 divided by 64.2. Is my z value going to be positive or negative? Because we are below average, right? And it is negative 2.56. Is it significantly low?
Yes.
Yes. Why?
Because it's less than -2.
Because we are less than -2. So, yes, it's significantly low. Does that make sense? This is kind of a way of determining. You don't, like yesterday when you guys were doing this, and even on your homework assignment, when they say, is this value significantly low? You would have to subtract the 2 and then find where it's significantly low. Now you can just calculate the z-score and compare it to 2 and -2, right? Okay. All right, let's go to over here and, all right, percentiles. Every time I go into the doctor, to the pediatrician, they tell me that my kids, like, I was just talking to Maddie about this. My kids' head sizes are like in the 95th percentile, meaning like they are like, their noggins are like basically bigger than 95% of all the kids in the United States-ish, probably. But they're in like the 5th percentile for like height and weight. I think one of my kids dropped to like the 3rd percentile for height at one point because I have short children. You guys have maybe seen my children before. I don't know about Kason. He might be better. But the 2 girls, they don't have a lot of hope, okay? So they're in like the 3rd percentile for height, okay? That means they are taller than only 3% of children their age in the United States. Let that sink in, because I've cried many a nights about this, okay? 3%, they're only taller than 3% of children their age. And probably what's happening is those 3% were preemie babies that already have a disadvantage that are going to eventually catch them, right? So we're really in bad shape. Okay, so they give me a percentile score, and that's what a percentile means. A percentile is the percent of people that are below you in whatever we're talking about. Okay, so if they say 3%, there's only 3% that are lower than my children. Okay. And that's kind of how that works. When we are dealing with percentile, when we're trying to calculate a percentile value, we take the number of values that are less than my value. This is me. And I divide by the total number of values, and I get a decimal number, which then I can convert to a percent. You can probably do that part in your head, though, right? Times 100, you're just moving the decimal 2 places. So the number of values less than me, number less than me, over total number. What do we use to represent the total number? What variable do we use? Like the total number in the data set. What's that? thing called N. This is kind of like N.
Sorry.
I don't know why I made it cursive N. That's an N, right? Okay, so the number of values that are less than me divided by N. And then I convert that to a percent and we go from there, okay? All right, finding a percentile. We'll do this one and then we'll stop, okay? Table 3-4 lists the same airport Verizon data stuff, whatever we've been dealing with, Verizon data speeds. This whole chapter, but they've usually only given me like 5 data speeds. This is all of them, right? And there are how many of them? 50? Did they say 50? Or you looked at the table? 10 across, 5 down, 50 total. So N is 50. Okay. And they want to know, find the percentile for the data speed of 11.8. And the good thing about this is they are in order for us. Yeah, they're in order for us. 11.8, this is me right here. And I need to figure out how many people are below me. How many people are below me? 2 full rows, which is 20, right? Okay, 20 people are below me out of 50, which is 2/5, which is 0.4. And if I convert that to a decimal or a percent or multiply by 100, I would be in the 40th percentile. If that is my data speed, that one right there, I am in the 40th percentile, meaning there's only 40 data speeds that are lower than me, right? I'm still about average range, right? 40 is still probably about average. But anyway, 40th percentile. Make sense? That's percentile conversion. Okay, we'll do the harder one tomorrow, which is converting percentiles to finding a data value. That's a different story. Okay, good? All right, I'll stop there.
Can we go back up?
Thank you.
What's happening here? Here we go. Oh, there.